Okay, welcome to the video 9.3 for constant acceleration formula 1. This is the examples for exercise 9C. Okay, so this is where we're going to derive a number of equations which we can use to answer problems later on. And they're called the Suvat equations, and they have 5 variables: displacement, which is S, initial velocity U, a final velocity V, acceleration A, and T for time. Okay, so this equation, this page summarizes it all, and we're just going to derive these equations. Okay, so starting with a particle here. Okay, so we assume this particle is coming from somewhere over here, and then we're going to start thinking about it when it gets to this point here. Okay, so we'll call this, it doesn't really matter what we call it, we'll call this point A. Okay, it has an initial velocity at point A, and it's going in that direction, so we'll call that U. It then continues to accelerate at a constant rate until it gets to the point at the end where we're considering, that is point B, and that has a final velocity. Okay, in between it's been accelerating, and we use a double arrowed line for acceleration. And then the distance between these 2 points we call S, the displacement. And the time it takes is obviously the time it takes to get from A to B. Okay, so let's put that onto a graph. So it starts at an initial velocity U, it then accelerates, so it's got a constant rate, so it's got a straight line and with the same gradient, and it gets to a final velocity V. So here is U and here is V. Okay, first of all, let's consider the area under the graph. So this was at time 0 and this was at time t. So this length here would be t, this length here would be U, and this length here would be V. So the area under graph gives us displacement. So S is equal to the area of this trapezium. So it's U plus V over 2 times by T. Okay, and that's simply the equation that we're going to use for displacement to start off with. Okay, then we can also think about the gradient of the line. So the gradient of the line is the change in velocity over the change in time. So the change in velocity is, let's get a dotted line now. Is this amount here, which would be V minus U. And that is divided by the change in time T, and that will be equal to, so the gradient of this is equal to the acceleration. So let's rearrange it so we've got it in a nicer form. So we're going to multiply by T. So V minus U is equal to AT. I'm going to add on U. So V is equal to U plus AT. Okay, so these are the two formula we're going to start from, and we derive these straight from this simple graph given this simple situation. Okay, so you need to be able to derive those in the exam. Right, using those in a couple of examples, so let's write those down. S is equal to U plus V over 2 times by T, and V is equal to U plus AT. Right, the cyclist is travelling along a straight road. She accelerates at a constant rate from a velocity of 4 meters per second to a velocity of 7.5 meters per second. Find A, the distance she travels in these 40 seconds, and B, the acceleration in these 40 seconds. So starting off with, for all these questions, write out what you know to start off with. So we know the distance. No, we don't. That's what we're trying to find out in part A. Do we know the initial velocity? So it starts at 4 meters per second and it ends at 7.5 meters per second. We don't know A and we're not trying to find it. The time is 40 seconds. Okay, so which of these are we going to use? Well, we're trying to find S. So S is equal to U, 4 plus 7.5 over 2 times by 40. Go straight into the calculator. So it's 11.5 on that first one, the top, over 2 times 40, 230 meters. Okay, we know it's meters because it's meters per second here. Okay, part B, find the acceleration in these 40 seconds. So for acceleration, we're going to use this one because this one has acceleration in. So we've got 7.5 equals 4 plus A times 40. So 40A, and this would be 4. So 40A is equal to 7.5. Take away 4, 3.5. So A is equal to 0.0875 seconds. Sorry, meters per second squared. Okay, moving on to example 5. A particle moving in a straight line from point A to point B decelerates at 1.5 meters per second. The velocity of particle A is 8. The velocity of particle at B is 2. Find A, the time taken. So S, U, V, A, T. S, do we know? No. And it's not part of the question to start off with. U, the initial velocity is 8. V is 2. The acceleration is negative 1.5. It's decelerating. And T, we are trying to find. Okay, what are our two formulas? S equals U plus V over 2 times by T, and V equals U plus AT. Okay, so I haven't got S. I'm trying to find T, so I'm going to use this second one. Okay, so V2 is equal to 8 plus negative 1.5 times T. So I'm going to add on this 1.5T, take away that 2, and then divide by 1.5. That goes in 4 times, so T is equal to 4 seconds. Part B, the distance from A to B. So I'm going to use the other equation. So S is equal to 8 plus 2 over 2 times by the time, which we just worked out, which is 4. So 10 over 2 is 5. 5 times 4 equals 20 meters. Okay, part C. Do it over here. After reaching point B, the particle continues to move along the straight line with a constant deceleration of 1.5. So that stays the same. The particle is at point C 6 seconds after passing through point A. Find the velocity at the particle of C. So we've got a new scenario, so we're going to set this up again. So S is, we don't know. U is, because we're talking about A through to C, so U is going to be the same as it was initially. And V, we do not know. That's what we're trying to find out. And A is still negative 1.5 and T is 6. Okay, here's my formulae. I'm trying to find out V, so it's got to be the second one. V is equal to negative 1.5 times by 6 will be negative 9. So V will be equal to negative 1 meters per second. Now that obviously negative 1 meters per second means it's moving back towards the initial point where it started from. The distance from A to C, so S is equal to U, which is 8 at negative 1 over 2 times by the time of 6. S is equal to 7 over 2 is 3.5. 3.5 times 6, 1821. A to C is 21 meters. Okay, next. Number 6, convert all your measurements into base SI units before substituting these values into the formula. So it's really important you have a look at and read the question carefully. The car starts from rest at the traffic lights. 30 seconds later, the car passes through a speed trap and is registered at 45 kilometers per hour. Okay, so notice we've got seconds here, kilometers per hour here. So we need to change. So we've got seconds in both of them. Okay, so let's write out what we've got to start off with. So the time is going to be 30 seconds. The car starts from rest, so it starts at 0. We want to find the acceleration. As it passes through here, it's registered at 45 kilometers per hour. Okay, so 45 kilometers per hour is equal to 4,500 for 45,000 meters per hour. So times it by 1,000, and then I need to divide it by 60 times 60. 60 seconds in a minute, 60 minutes in an hour. So divide it by 6 times 60, which is 3,600. We could just divide it by 3,600. Gives us 12.5 meters per second. Okay, so this would be 12.5. Okay, generally it's always best to work in meters per second for these, unless you're told to do otherwise. Find the acceleration of the car. So what formula has acceleration in? V equals U plus AT. So 12.5 equals U 0, so I'll leave it out, plus 30A. So A is equal to 12.5 divided by 30. .42 to two significant figures. Meters per second squared. Part B, distance between traffic lights and the speed trap. So that's S is equal to U plus V, so it's just 12.5 on the top, over 2 multiplied by the time 30. .187.5 meters. Okay, we could have done it in kilometers per second, but it doesn't really make much sense to do it that way. Right, so have a go then now at exercise 9C.